All right, so this video we're going to continue on with 1.3c, solving absolute value equations. So we need to talk about what's called an extraneous solution. I also call it an imposter because it's basically a solution that looks like it's an answer, but when we look carefully, it's actually not. So the definition is a solution of a simplified equation that is not a solution to the original problem. And so these occur a lot. You're going to see the word extraneous solution a lot throughout high school in different contexts. But in the context of an absolute value equation, this is going to occur when the variable is on both sides. So this equation would be an example of one that would have extraneous solutions. Earlier this week, when we dealt with equations like this, we didn't have to deal with extraneous solutions because there was no variable on the other side. So let's take a look and see how we're going to determine if a solution is extraneous or not. So for example, for this first one, we're going to solve exactly the same that we've been doing. We're first going to make sure that the absolute value is isolated on one side, which it is. And then we're going to make two equations. The first one, the inside stays the same. The outside is the positive answer. And then on the other one, we're going to keep the inside the same, but make it the negative answer. And then we're just going to solve each of these equations for x. So this first equation is giving me x equals 5 as my answer. And the second equation, when I solve it for x, is giving me -1 as my answer. But with these types of equations, we need to check both of our solutions to make sure neither is an imposter or is an extraneous solution. So I'm going to take -5 and I'm going to replace it for x in the original problem. So I get 4 times 5 plus 10 is equal to 6 times 5. 4 times 5 is 20, plus 10 is 30. The absolute value of 30 is equal to 6 times 5, which is 30. So 5 is a solution. Now let's try -1. So I'm going to do 4 times -1 plus 10 is equal to 6 times -1. 4 times -1 is -4, plus 10 is +6. The absolute value of +6 is not -6. So since that's false, we're going to put a cross through the solution to show that it was an extraneous solution. It was an imposter. It looked like it was our answer, but when we plugged it in, we found out that it didn't actually work. All right, so for this one, let's make sure that our absolute value is isolated. It is, so we can jump right into solving. So my first equation is 2x plus 5 equals 3x plus 4. So the same exact thing with no absolute values. For the second one, I need to make it opposite or the negative version of my answer. And so I have to do negative of the entire thing. So that really gives me -3x and -4. And so if I solve each of these, this equation is going to give me x equals 1. And this equation is going to give me a fraction. It's going to give me -9/5. So let's go ahead and check and see if these are extraneous. So I'm going to plug in 1 for x to the original equation. 2 times 1 plus 5 is 7. 3 times 1 plus 4 is 7. So this is true. So 1 is a solution. Now we have to check -9/5. So we're going to do 2 times -9/5 plus 5 is equal to 3 times -9/5 plus 4. So 2 times -9/5 gives me -18/5. And I want to make a common denominator so I can add these together. So that should be 25/5. And then 3 times -9/5 is -27/5. And a common denominator of 5 makes this 20/5. So adding -18 fifths and 25 fifths together gives me 7 fifths. -27 fifths plus 20 is -7 fifths. The absolute value of 7 fifths is not -7 fifths, so -9 fifths is not a solution. So I know in the last two problems, we've only had one solution for each of them. That's just a coincidence. We could have both be true or we could have both be false. And so it's really just up to the individual problem how many solutions we have.